Part C of the roller coaster problem tells us that we have horizontal beams that are placed 2 meters apart, and we want to find the length of the horizontal beams. So we're trying to find lengths going this direction. All right, if I go over here, here's our function, and here's a picture of what the graph looks like. So what I'm really trying to figure out is, the horizontal distance here. So on my graph, I'm really trying to find this length right here. That would be the length of my first horizontal beam, okay? And if you look at that beam, the key thing is those are all the points where the y value is equal to 0 along there. I need to figure out, what I'm really trying to figure out is the coordinate of this point right here. We know the y coordinate is 0. The x coordinate will tell us how far over from the axis it is, and that's what will enable us to be able to come up with that horizontal distance. So I know y is 0, I just don't know x. So if I come back to the original equation, I know y is 0. I just need to figure out what x would give me a y value of 0. I just need to solve that equation, okay? So in a way it's a complicated equation, in a way it's not. You really want to get the trig function isolated, okay? So subtract 12 from both sides, and you'll end up with an equation that looks like this. And again, you want to isolate the cosine, so divide both sides by 15. And I think that's negative 0.8 if you really like decimals here. And so you can write it like that. And that's equal to cosine of pi over 50x. Now keep in mind, this is all part of the cosine. Okay, so if you think back to geometry, normally you put in an input and you get out an output. And what we're really trying to do is we're trying to get to that x value. Remember, we have the inverse trig functions that allow us to switch the input and the output. And that's what I'm going to use here. So I'm going to take an inverse, or sometimes it's called an arc cosine, of negative 0.8. And that's going to be equal to pi over 50x. Okay? So I just switched the input and the output, and that's what the inverse trig functions allow me to do. I just switch whatever you put in, whatever you're taking the cosine of, with whatever your output is. And we get an equation that looks like that. So I'm going to jump over to the calculator here. We are working in radians in all these problems, so do make sure your calculator is in radian mode before you do anything. And once we've taken care of that, we will take the inverse cosine. You can hit second in the cosine button of negative 0.8, and that's going to be about 2.498. I'm actually going to leave all that in my calculator, but anyway, I'll just kind of write this over here on the board for now. We just need to solve that equation. So you can divide both sides by pi over 50. Remember, if you multiply a number by its reciprocal, you end up getting 1. So if I multiply this side by 50 over pi, and I balance this side by multiplying it by 50 over pi, the pi's will cancel, the 50's will cancel, we'll just be left with x over on the left. And so what's really happening is that decimal is getting multiplied by 50, and it's getting divided by pi. So let's multiply that by 50, and then we'll divide that answer by pi, and we get a final answer of x is about 39.758. Now, and that's saying that this is about 37 or 39.758 feet over. Okay, that would be the point. 39.758 comma 0 is what's really happening there. By the way, this can be done on a calculator. If we go back here and we graph this, and I set my window up already, there's a function on your calculator called the calculate function. You can hit second in the trace button, and you get a list here. Remember, this feature on the graph was actually the location of the place where the function was equal to 0. That's called a 0 of the function. Y is equal to 0 there. There's actually a function on your calculator that allows you to find the 0 if we haven't used this in class previously. So you can go to second and then the calc button up here, and you get this list. Choose 0. What it'll allow you to do is it'll ask you for a left bound. Go to a point to the left of where it crosses the axis. And you do have to make sure your window is set up to show the graph the way you want it. But you can hit enter on the left bound. So pick a point to the left of where it crosses the axis. Then it asks you for a right bound. So go to the right of where the point crosses the axis and hit enter. And there's a guess here. You don't need to fill in the guess. Just hit enter again. And it'll test all the values between the left and the right-hand point, and it'll give you that point right there. And you can see it's 39.758 units over, and the y-coordinate is 0. So again, no algebra there, but another way to do it. Now, this function problem asks us to find the lengths of all the horizontal beams. It said going every 2 feet. So if you go back here, they also want the length of this beam right here. And notice now we have a y value of 2, and we're trying to figure out the x value. And so really, same kind of thing. You can set the function equal to 2, and you can basically go back and you can undo pretty much everything we've done previously and kind of continue with that. So, so I'll go ahead and try that here. I've got 2 is equal to 15 cosine of pi over 50 x plus 12. And you can subtract 12 from both sides, and you'll get negative 10 is equal to 15 cosine of pi over 50 x. And then you can divide both sides by 15. The process is exactly the same. So you get negative 2/3, negative 0.667 is equal to cosine of pi over 50 x. Okay, we want to get to this x, so I want to switch the input of the cosine function in the output so I can get that x out of parentheses there. So we'll take the inverse cosine, or the arc cosine, of negative 0.667. Again, if you could leave that decimal in your calculator, it's negative 2/3. That's actually a little bit better. And that's equal to pi over 50x. So we'll go over here, we'll do that. We'll take the inverse cosine of, it was negative 2/3 actually, or negative 0.6 repeating, but it's a little better number to put in there. And so we're going to be left with about 2.3005 is equal to pi over 50x. And you can multiply both sides by 50 over pi. And that's really the same thing as multiplying by 50 and dividing by pi. So we'll multiply that answer by 50, and then I'll divide that by pi, and we get an answer of about 36.613. And that should make sense if you think about it, because if you notice, this is a little bit shorter than that piece there. So we know the y-coordinate's 2, the x-coordinate is 36.613. By the way, you could also do this on your calculator. You could graph the line y equals 2, which would be the horizontal line passing through 2. And if you graph that, you can kind of see right there, this point where the two things intersect, you would want to know the coordinate of that intersection point. And there's actually a function in your calculator. If you go back to second and calc, there's also an intersect option. It's choice number 5 here. And it'll ask you to trace along one curve. Basically, trace kind of close to the intersection point between the two curves. And then it'll jump to the other equation. And you can hit enter on both of those. And again, just hit enter on the guess. And notice it tells us the intersection point is when y is 2 and x is about 36.613. So it can be done on a calculator, but again, should also be something that you can solve algebraically. And of course, you'll continue with this in this problem. To find the next one, you'll set the equation equal to 4, and that'll allow you to find the horizontal length, and then 6, and then so on. But I'll let you finish that part of the problem.